This LOS is explain the central limit theorem and its importance. The central limit theorem. The central limit theorem states that for large sample sizes, for any underlying distribution for a random variable, the sampling distribution of the sample mean for that variable will be approximately normal, with the mean equal to the population mean for that random variable and variance equal to the population variance of the variable divided by the sample size. Based on the central limit theorem, when the sample size is large, we can compute confidence intervals for the population mean based on the normal distribution, regardless of the distribution of the underlying population. In general, a sample size of 30 or larger can be considered as large. Definition of the standard error of the sample mean. For sample mean calculated from a sample generated by a population with a standard deviation, the standard error of the sample mean is given by one of two expressions. So the first one is when we know the standard deviation, the population standard deviation is the standard deviation divided by the square root of n. That's the number of samples that you've done. When we do not know the population standard deviation, then it's also the standard deviation, but it's the standard deviation of a sample divided by the square root of n. We need to use the sample standard deviation to estimate it. In practice, we almost always need to use equation number 2. The estimate of S is standard deviation of sample is given by the square root of the sample variance. So I've just put the formula down here again for variance, which is the sum of x minus x bar squared divided by n minus 1. And we recall that standard deviation is the square root of the variance. And that is the last slide for this LOS. Thank you.